Hello friends, today we are going to learn chemistry of class 12th. In that chapter, in that subject we have to learn 16 chapters, and the first one is solid state, followed by solutions, electrochemistry, chemical kinetics, surface chemistry, general principles and process of isolation of elements, 7th p block elements, D and F block elements, coordination compounds, haloalkenes and haloarenes, alcohol, phenols and ethers, aldehydes, ketones and carboxylic acids, amines, then biomolecules, polymers, chemistry in everyday life. These are the 16 chapters you have to learn. You have to learn. So first itself we can go to the solid state. Here I am only going to explain you the focus area topics. Solid state. Solids are substances having definite shape and definite volume. In solids, the particles are closely packed and the force of attraction between the particles is strong. The classification of solids based on the structural features, the solids are being classified into two: crystalline and amorphous. In crystalline solids, there is a long range order and there is a sharp melting point and heat of fusion. It is anisotropic in nature, which means the physical properties are different in different directions. Example, quartz and diamond. In amorphous solid, it is a short range order and there is no sharp melting point and heat of fusion. It is isotropic in nature. Isotropic in nature means the physical property are same in all the direction. Example, plastic and rubber. Based on the nature of particles, it is divided into four: molecular solids, ionic solids, metallic solids and covalent solids. In molecular solids, the example is HCl, HCl and SO2. In ionic solids, those are NaCl and MgO. In metallic solid, it is Fe, Cu and Ag. In covalent solids, it is SiO2 and C. Crystal lattice. The regular three-dimensional arrangement of constituent particles of a crystal in space is called crystal lattice or space lattice. The unit cell. A unit cell is the smallest repeating unit in a large crystal. The types of unit cell. There are two types of unit cell. The first one is primitive unit cell and the second is centered unit cell. In primitive unit cell, the constituent particles are present only at the corners of unit cell. And the centered unit cell, the constituent particles are present at the corners and other position of the unit cell. Based on that feature, it is again divided into three: body-centered unit cell, face-centered unit cell and end-centered unit cell. Here, the constituent particles are present at the body center and also at the corner, so it is named body-centered unit cell. If the constituent particles are present at the center of each face and also at the corners, it's called face-centered unit cell. The next comes is the end-centered unit cell, in which the constituent particles are present at the center of any two opposite faces and also at the corner of the unit cell. And then comes the number of atoms in different cubic unit cell. In primitive it is 1, in body centered it is 2, and in face centered it is 4. 1, 2 and 4. The next comes is close packing in solid. In close packing in solid the particles are closely packed. In close packed particles, the particles are considered as a hard sphere. And the packing efficiency means the volume occupied by all the spheres in a unit cell into 100 divided by total volume of the unit cell. The type of closed packing is the first one is FCC or CCP or HCP. The packing efficiency is 74%, and in BCC it is 68%, and in primitive or simple cubic it is 52% respectively. The imperfections in solids or the crystal defects. The deviation from a regular orderly arrangement of particles of a solid is termed as imperfection or crystal defects. The crystal defects are broadly classified into two: point defects and line defect. If in a point defect, the imperfection is around a point in a crystalline substance. For example, an atom. In an atom, there if the imperfections are coming in an atom, we call it by the term point defect. In the line defect, the imperfection is along a row. So the point defect are again classified into three types, that is non-stoichiometric defect, stoichiometric defect, and at last impurity defect. Okay, the point defect means the imperfection is around a point in a crystalline substance. Then